Yo, what is up YouTube? In this video, we're going to prove the compound angle theorems for sine and cosine. So these are the theorems. Let's tackle this using Euler's equation. So e to the ix equals cosine x plus I sine x. And that's like proved by some smart guy like 200 years ago or whatever. So first step, we're going to see what e to the I a plus b is. So wherever we see an x, we're going to throw in the a plus b. So we got cosine a plus b plus I sine a plus b. In step 2, we're going to do it a slightly different way so we can get something equivalent to compare it against. So we're going to distribute the I into the a plus b and get e to the ia times e to the ib. So now for e to the ia, wherever we see x in this upper equation, we're going to be putting in an a, and for the e to the ib, we're going to be putting in a b. So we get cosine a plus I sine a, and then cosine b plus I sine b. Now, what we have to do is, to get the equivalent expression, e to the ia times e to the ib, we have to multiply these two expressions, because that would be equal to the multiplication of e to the ia times e to the ib. So we get cosine a plus I sine b, or I sine a multiplied by cosine b plus I sine b. And what we have to do now is FOIL out these terms. So that looks like cosine a times cosine b, and then cosine a times I sine b, and I sine a times cosine b, and I sine a times I sine b. So here I'm multiplying out these terms, and I get cosine a cosine b plus I sine b cosine a. And now I'm looking at the next one, which is I sine a cosine b. And then the next one, it's I sine a times I sine b. So we get I squared sine a sine b. And if you notice, we have this I squared. I squared is equal, or I is equal to the square root of -1. So I squared is the square of the square root of -1, which is just -1. So we could rewrite this one as like negative sine a sine b. So this is looking good so far. What are we going to try out and like figure out what these things are equal to now? So we can group all the imaginary terms and all the real terms together. So imaginary terms are ones with I in them. Real terms don't have I. So we have cosine a plus cosine a cosine b minus sine a sine b, and those are the real terms, and we're getting that minus sine a sine b from this one where we converted the I squared into -1. And then we're going to factor out this I here, and then put these two terms in, sine b cosine a and sine a cosine b. I think I got confused up here when I was looking at my little parenthesis for the a, because it looks like an H a little bit there. I don't know what's going on, but now we have these real and imaginary terms all grouped together, and all of this is equal to e to the ia times e to the ib. That's why we're doing this, because that expression is equivalent with e to the ia plus b. So let's take a look at what we're doing. We have this term that's going to be equivalent to the term we found earlier. So that term earlier was e to the I plus b, which is equal to e to the I times e to the ib, right? So now we have cosine of a plus b plus I sine of a plus b, which is going to be equal to what we just found in this above equation. That's all highlighted in blue, or underlined in blue. So we can kind of match up these real and imaginary parts. We see we have these real parts, on the left, and then we have these imaginary parts over here on the right side. And that's going to be I times sine b cosine a plus sine a cosine b. So this is nice. This is looking good. Now all we have to do to complete this proof is match up all the imaginary terms with all the imaginary terms, and match up all the real terms with all the real terms. So we have cosine A plus B is equal to cosine A cosine B minus sine A sine B. And this is looking very familiar because that's the compound angle theorem for cosine. That's awesome. Now for sine, we're looking at the imaginary terms. We have sine A plus B is equal to sine B cosine A plus sine A cosine B. Awesome stuff. So right now, I'm pretty sure we can conclude our proof because if we scroll up, we have these equivalent statements, and we go ahead and come down here and write therefore with 3 dots, and then QED, which pretty much means proved, and we'll circle that. And yeah, that's a fun little proof.